In the mountains, just 120 kilometres east of Melbourne, is Woods Point, an old mining community that refuses to die. It all started in 1861. Prospectors running out of alluvial gold at Castlemaine and Bendigo headed for the unexplored mountains. They found gold in the alluvial gravels, but the real prize was not in the rivers, but in the surrounding hills. In most Victorian mines, the gold-bearing veins occur in sedimentary rocks, like sandstone and shale. But the Morning Star veins are different. They're hosted within an igneous intrusion or dike. I went underground with Dr. Peter Jackson to see this unusual host rock.
This host rock is called a gabbro. It's a coarse-grained igneous rock. That is, it has formed as a result of cooling of magma at depth below the Earth's surface. And we can tell that because of the coarse interlocking texture.
The Morning Star gabbro intruded folded sedimentary rocks 376 million years ago. There are many other igneous intrusions just like it, but this is one of the largest.
Where we're standing, at this point, the dike is about 100 metres wide, and towards the edge of the dike, the grain size decreases because of more rapid cooling.
After the gabbro had cooled, external compression fractured the dike, and this created a network of low-angle faults that can be seen throughout the mine. Above the workings in the company's office, their computer model shows how the mine workings traverse the gabbro. But they've taken most care in modelling the low-angle faults, because that's where the gold is now found.
Okay, you can see reef on our left-hand side there, and also reef on the right with some brecciation.
So this is Tills Reef, Peter?
That's correct.
Now, you said before that this was a relatively low-grade reef, relatively low content of gold. What's special about this location?
Well, this is a good spot to get a 3D perspective of the reef. As we were walking along the drive, the reef appeared to be horizontal, but you can see that at this position here, we can look up and see the reef rising to my left and sloping down to my right.
So Tills Reef is simply one of the low-angle faults that was then infilled with quartz. Another part of the reef shows evidence of brecciation.
And if you look very carefully, you can see that the reef here is made up of angular fragments of the dike rock hosted by quartz. We call this a breccia reef, and this type of reef is fairly common within the mine. As you can see, the clasts vary in size from very small, this one here, up to slightly larger, this clast here, and even larger still. And I think that what we're looking at here is mechanical breakup of the rock, which has produced these fragments, and later movement has been taken up by these laminated veins on the hanging wall and on the footwall.
Faults that had repeated movements are better hosts for gold. So Peter is always looking for evidence of a complex movement history.
Yes, Clive, this is White Loss Reef, and it's formed along a large reverse fault. If you examine the reef very carefully, you can see evidence of a number of periods of movement along that fault. If you look towards the hanging wall of the fault, you can see that the quartz up there is moderately laminated. These very fine lines that you can see running through the reef there are laminations, and those laminations form as a result of successive movements along the fault. So it's layered, whereas towards the centre of the reef, the quartz is more massive. Most commonly you find grains of gold along the laminations. So along these laminated layers within the quartz reef is where you find most of the gold.
Before closing in 1962, the Morning Star produced up to 800,000 ounces, a mighty effort for a small mine. But many of the old stopes were exhausted. So 50 years later, The challenge for the new company is to find new reefs. They can use traditional rising and driving, but diamond drilling is the best way of finding new quartz. The core can also help Peter to understand the geology of the deposit. So what have we got here?
This black and white coloured rock that you can see here is the unaltered dike rock, and as we move towards a fracture represented by this vein, it's an infill fracture, we can see that there's a change in colour from black and white through green and grey, and that represents a zone of alteration.
What's actually happened? Is it the fluids seeping into the wall rock?
The hot fluids have moved up a fracture, precipitated material in the fracture, but also permeated out of that fracture into the wall rock. And one thing that you have to keep in mind is that these fluids are under high pressure and they can actually permeate through the rock around the grain boundaries.
Yeah, so it looks like it's altered the texture of the rock, but is it altering the chemical composition as well?
The chemical composition is profoundly altered. This light colour that you can see in there is due to the presence of carbonate minerals and also a mineral called sericite.
Which is like a mica, isn't it?
It's a very fine mica.
Okay. How can you use alteration in the exploration?
Well, the alteration only occurs with hot fluids. So it represents the period when gold is being transported by the hydrothermal fluids. Occasionally you find veins like this that don't produce very much alteration in the wall rock, and they're very late stage, lower temperature fluids that are carbonate rich.
So the alteration is a really useful key indicator to where gold may be.
It is, and you tend to get elevated gold in those zones of alteration.
Yeah. So you can get gold in the wall rock either side of the vein?
Certainly.
Okay.
Yeah.
For how
you always
far?
get elevated, not necessarily economic.
Yeah.
You always get elevated gold in the intense wall rock alteration.
Now what I really want to know, Peter, is just how the gold occurs in the veins, the distribution and the size of the particles.
The gold can occur in a number of ways in veins, but most commonly the high-grade ore veins are laminated veins. And we might be able to show you one of those. In fact, here's Fran now.
Well, that's a great example of lamination, isn't it?
You can see the laminations there, and you can also see the grains of gold along those laminations.
Did you find this, Fran?
Yeah, I found it on surface, yeah.
Okay. What, near here?
Just on the top flat, yep.
Okay, that's a beautiful sample. But Peter, you know, given the amount of gold in that we can see, I can see maybe half a dozen tiny little grains. Would that be considered rich enough to mine?
Certainly, you're probably looking at a grade of somewhere between 50 and 70 grams per tonne.
Which is fantastic, isn't it?
Fabulous. Yeah. In fact, some of our laminated vein samples have run well over 1,000 grams per tonne. There are the laminations, and there's the gold along the lamination.
There's a grain there. Is that a grain of gold there?
That's a grain of gold there, yeah. And there's a lot of very fine gold.
Yeah, I can see little parallel streaks of gold here.
When you find the gold forming along these laminations, for example, they often form a layer, a very thin layer of gold that covers the whole of the lamination. And if you break it along that lamination, it exposes a layer of very fine gold.
So when you say the grade of this sample would be roughly 60 grams per tonne, that's equivalent to 60 parts of gold per 1 million parts of quartz, isn't it?
That's right, and we could mine this underground at a grade of about 7 parts per million.
Yeah, it's fascinating that you don't need much gold. It barely has to be visible to make it pay.
That's true. In many places in Western Australia, the miners there have never ever seen gold.
But not so for the Morning Star mine. Some spectacular gold has been mined from deep below.
Well, one of the best samples that we've found came from Campbell's Reef on 7 level. It's a laminated quartz vein with a considerable amount of gold, but there are also some sulphides present, including pyrite and arsenopyrite. Very rarely do you see so much gold in a hand specimen. It's a very beautiful sample.
The Morning Star is one of the most unusual mines in Victoria. It may be 150 years old, but new exploration is giving Woods Point a whole new life.